So my name is Kyle. I started off my role as an engineer in hardware engineering, doing primarily product design for iRobot at the PCB, PCBA, and firmware level. When I left iRobot in the latter half of my career, I joined a small 3D printing company, also thinking, here's my opportunity to build a hardware workflow from the ground up. The green space for new opportunities, sky's the limit. Unfortunately, when I looked around, there's several things I didn't see. What I needed was a process to organize, design source documentation and release outputs. This probably looks pretty familiar to a lot of you. I needed it to be flexible without requiring manual exports, updating part numbers, or anything like that. And I needed it to be lightweight to set up and manage out of the box. We didn't have the budget to subscribe somebody full-time to managing a system. Looking around at the industry and kind of pulling from my previous experience, this is generally what I found. We had SVN, was pretty common in hardware, as a lot of you are familiar with from software before Git came around. I knew enough from my work in firmware and software on the side that the industry was really moving away from SVN. That Git was the new product that was pulling a lot of development, getting a lot of support, had great documentation, and really pulling the industry forward. So SVN was kind of looking not like such a good option. There was also PLM, which stands for Product Lifecycle Management. If all of you have not had the pleasure of working with PLM systems, they're essentially pretty straightforward object data storage with kind of brutalist UI, proprietary APIs, and all sorts of kind of fun interfaces like that. And were and still are very common in hardware design, generally used more for managing with suppliers, working with operations team, where we kind of are looking at as the deployment for hardware engineering now as we look for the future. Of course, we also had Dropbox and shared file, network file storage. You get such fun, system or workflows in this kind of Wild West style of product design, where you get v1.0, v2.0, v2.0 final, v2.0 final, and then okay, really final. We're serious this time, and that's what ships out the door. We also saw that we needed that the industry was very dependent actually on real-time, in-person design reviews, and that also didn't feel right to us. We saw a lot of young hardware companies moving to GitHub, and that's ultimately what we ended up doing. When we looked around at a lot of our contemporaries in hardware startups, that was the big trend. But unfortunately, like most of them, we ran into very limited capabilities, especially when it came down to binary files. No diff, which meant we really couldn't do a merge request. We really couldn't do branching. Even releases, we were not finding a lot of support and didn't take full advantage of. So it became kind of just the simple, most basic level of version control that we could have. When we look across the system of hardware design, this is not an easy problem. There are lots of tools. We have CAD design tools, documentation, and right in the middle I put email, or as hardware teams like to call it, continuous deployment. And that all has to come together and be connected together, usually with systems that aren't meant to integrate right out of the box. So, software had a lot of the same issues, but ultimately ended up moving from SVN to Git pretty much universally at this point. So why is hardware not there yet? Change is hard, of course. And hardware generally has been able to get away with it because of, get away with some inefficiencies at the very least, because in part of waterfall design. Waterfall design is a project management structure that essentially you do a lot more planning up front to align your various teams, to align your various products. You'll maybe do 5, at max maybe 6 releases throughout a year, and they're pretty well defined ahead of time. And so that was one of the reasons it could kind of get away with doing fewer releases, having inefficiencies, because it wasn't impacting them as much. You also had all of these, one of the other frictions was you have these, all these file formats and integrations that I showed on the previous page. A lot of them are binary formats, very deliberately from the industry built up walled gardens. The typical product release cycle in hardware was to, if you wanted to introduce a new product to the industry, you would get everybody to use your CAD design tool and then build out that ecosystem around it, and didn't really play well with others, which is still a lot of the case in the industry. And then there's also this kind of, last couple is just the focus, less of a focus in hardware on, or potentially even obsession of productivity in the hardware space as compared to software. In fact, a lot of hardware teams are still somewhat focused on getting first pass success, partially because of some expense that goes with designing new hardware projects, but partially because of the culture that's built up in the hardware ecosystem. And then, of course, the learning curve. I think software engineers are a little bit more predisposed to viewing Git as a tool that they can use and learn to really augment themselves as designers and developers. So just to dig a little deeper, technical limitations are large binary files, doesn't play nicely with Git delta compression, very few tertiary features that you may get from a broader GitHub or GitLab ecosystem, the long release cycles, waterfall methodologies, and needing alignment for teams, and then org-wide communications really became frictions in this space. So that all being said, what's changing now? I'm sure a lot of you have heard about stock and supply chain issues, or at least seen them when you've gone to maybe acquire a new graphics card or a car or basically any electronics device in the last 6 months. So all of a sudden, the designers that are behind these systems are no longer allowed to get away with these kind of very forward-looking release cycles. All of a sudden, they're getting notes from factories in saying, we're going to have to shut down the factory or the product line because we can't get some chip, and you need to design a new chip, qualify it, and release it in the next few days. Otherwise, we're shutting things down. There's, of course, the move to remote teams, largely due to COVID. There's the push to improve relationships with contract manufacturers and a lot of new capabilities for quick-term prototyping. So that cost that we had earlier for potentially the perceived cost that it's going to cost us a lot of money and take a while to get a design, so we better have it right, is kind of going away. You can get PCBA designs in a couple days at least. It'd be a long compile time, but it's something that at least is manageable. And then, of course, there's the pressure to iterate designs to keep pace with changing consumer demands and technologies. All these pressures to move faster, especially when a lot of the other teams hardware engineers are working with are also able to move so much faster. So Git has enabled software engineers to iterate very quickly, be very flexible, be nimble. Even tools like 3D printing in mechanical engineering has allowed mechanical engineers to move quickly, to get confidence in their designs very quickly by doing full fit, form, and function checks. And this one is just ripped straight out of our pitch deck. I mean, this is a huge deal. It's costing the industry a lot of money. I expect a lot of you in the room have felt this, and it really needs to be addressed. Here's some of the headlines you've seen. Even straight from the users of our, of Git in hardware are saying, we're playing whack-a-mole. What we need is flexibility. So the day of manual exports, in-person design reviews is going away. OK, so our company exists largely because we believe that at the end of the day, there are a lot more similarities than there are differences in hardware and software designs. For instance, similarities, of course, the desire for organized design data, revision control, and review. Asynchronous collaboration. Desire for automated design validation and release. Supported documentation alongside design data. Markdown has been a huge impact here that the hardware folks are starting to warm up to. And concept of design review, which we have branded as or concept of pull request, which we're branding as design review generally. and then tagging and releasing versions and kind of organizing the output and release files. And the differences are important too. For one of the biggest technical and usability differences is that we're generally working with vector graphics design data, schematics, and printed circuit boards. A lot of times those are binary, but not always, because of the bullet point above. Even if they're not binary files, presenting a user a schematic textual difference isn't very important because they're so used to seeing things visually and consuming information that way. There's also generated output design files included in reviews. This is an area where I actually think the hardware folks have something to teach software a little bit, because I think this desire for reviewing the outputs, whether that's compiled code or whether that's a new UI in software, as part of a pull request is important. But in the hardware communities, they're so used to doing this that it's kind of expected coming in. And then there's the strong need for sub-assemblies and assemblies, some way to link together multiple projects and repos. Lots of supplemental data, tests, simulations, et cetera, that exist in software, but much less common. So to dig a little bit deeper and see what this looks like, our company really exists to kind of run this translation from software to hardware, applied to hardware. And what you might expect in the software space is a textual diff. Green highlighted text, red deleted text. What we show is green highlighted elements, red for deleted elements in a visual format. You would expect inline code comments in design reviews. What we've introduced in the market is visual snippets. And then when we look at CI/CD, in terms of unit tests, integration tests, well, there's this whole concept of simulation and so much information that we can kind of give to the users, give to the hardware engineers about their design that is currently actually being withheld from them. And this is what that looks like. So for diffs, on the left, you can see your typical textual diff. And on the right, you can see, hopefully it's not too small, but we have green for highlighted components in here, red for removed, and we've also introduced yellow for modified components. The visual information is important, so is the textual metadata, as we generally refer to it in the hardware designs. So this is what our snippets look like on the left, in code, comment, feedback. And then on the right, you can grab a specific section of your design, and you can comment on that for feedback, tag somebody just like you would in software. That all becomes part of the design review, part of that kind of immutable documentation that you get as part of just using a Git workflow. And the really exciting part for us as we start to look forward into this year and into next year is CI/CD. So just like Git, built up this whole world of CI and CD that so many of us are working in today, we see the same thing happening in hardware. There's no limit to what we can test with component information and really allow a flexible system for users and hardware engineers to design their own tests. This can go all the way from, I have an example here of a kind of fit and mounting point test that could be visual. Or you can have checking of component stock and supply information from either open available sources or customized data inputs. So we've introduced that. It's been really exciting. It's been awesome to work on. We're kind of laying the groundwork for Git for hardware design. As we're continuing to build for the future, we have a lot of really interesting technical problems that we're continuing to solve. These are some of the areas where myself and my colleagues are at this event even to learn a little bit more about. We still have to help our users better manage binary and large files. Is LFS going to be the solution there? Maybe. But we also look at potentially extending our implementation of Git to have hooks that maybe transform data into a more delta compressible schema. Ecad file merging is a big deal. We really want to help introduce the full power of Git to hardware communities, which are kind of still at a bit of a half measure because we generally recommend 2 branches because files at the hardware level do tend to conflict if you're trying to bring them together. Again, we have potential solutions that we're really pushing on, we're really excited about. The release process, as I mentioned before, including new design files, really important for hardware teams. And one that I think the broader software orgs can kind of look at and think about. We look at, for instance, similar to how wikis exist in GitHub repos, having kind of parallel mirrored repos for design outputs that maybe you don't have to be included in the source to kind of clog things up, but still can be revved alongside the source information and be reviewed and be contained. And then finally, we have assemblies and sub-assemblies. I'm actually very interested to see the talk and listen to the talk after me, because Git submodules is still a really interesting technology that we want to put to use in hardware. But there's other also competing solutions for organizing larger multiple repository orgs that we're interested, such as like GitLab subgroups. Of course, the beauty of building on top of the Git is that we have either the base functionality or the plumbing for so many of these things. I mean, Git has been extended to so many directions that it's been a technology that's really enabled us to build out some of these capabilities, no matter where the industry tends to pull us. It also aligns really well with software. Integrators for GitHub and GitLab and in Bitbucket as well have been really helpful, especially when we talk about, we see hardware engineers becoming more and more software savvy and working even closer with the software teams. Having them be able to come into a system that they completely understand has been really helpful. Helps teams just iterate faster. We know we need to get them more flexible. We know we can't accept a 3-week in-person scheduled design review. It has to be async. It has to be digital and remote. And then it's integrated and customizable. So we need to break down the barriers of walled gardens, proprietary software, and proprietary interfaces, and expose data to consumers, let them connect it to the other tools that they're doing. We have no intention of being the best in class for every single thing that the hardware engineers are doing in their day-to-day workflow. So being able to connect to other tools is really important. And it needs to be easy to adopt yet scalable. We're not hiring consultants to come in and set up a Git solution at a startup. It's just not gonna happen. And more we see even the larger companies want to democratize their data management. They want to enable their engineers to do more of their design, have more control and autonomy over what they're working on, because we view repositories are really an extension of engineers, a really extension of designers to be able to say, hey, this is how my design data is going to be presented and how I'm going to communicate it. So of course, at the end of the day, just to recap, we get a faster time to market for hardware companies, more accountability, decreasing errors, breaking down silos between teams, which is a huge source of those errors, and being proactive versus reactive. Setting up tests, for example, is a great way to kind of think about building up a solution for something before we see it come back to us in production. So once we get there, we really see the growth of CI and CD in hardware. We see cross-disciplinary teams coming together, test-driven development even, pulling it from software, translating that to hardware, and a new chapter of open source formats and integrations. And that's really it. I think we have time for maybe 1 or 2 questions if we have the mic available. File locking. Yeah, so one of the things that Git LFS does enable is ability to lock files. We have mentioned that to some of our super user customers, but for the most part, file locking hasn't been one of the really required features. In fact, for the most part, our users are not using LFS at this point. Yeah, absolutely. I mean, we definitely have started to see a lot of the grumblings of chip manufacturers wanting to get their parts in front of customers. I mean, at the end of the day, our customers are their customers. So us being able to be the middleman between the chip manufacturers and the engineer at the end of the day is really desirable for them. There has been a lot of efforts to standardize some chip information and data. PDF has generally been the old way of doing things. Not surprisingly, they're going away from that into more again, standardized in text-based encodings. All right, I think we can wrap it.